Many students find the topics of dynamics very challenging because forces cannot be seen. To master the topic of dynamics, it is important to be able to identify the types of forces acting on an object. Hence, in this module, we are going to cover various types of forces, and with the help of free body diagrams, you will be able to easily solve dynamics questions. We'll begin the first lesson on a force that acts on all objects, that is weight. Before we go into the details of weight, let's take a quick look at the various types of forces. Apart from a push or pull that we may exert on an object, the rest of forces are not visible to our eyes and may not even be felt by us, though they exist. Hence, to help us understand the effect of forces acting on an object, we make use of free body diagrams, where we use simple block diagrams with arrows representing forces and their directions. Drawing free body diagram is simple. However, we need to know what are the forces acting on each situation, and that is the whole objective of this module, where we will cover these 4 types of forces which are not visible but they exist. So let's start with weight. One important force acting on any object is the weight of the object. But first, let's look at the difference between weight and mass. The weight of an object is a force due to gravity. When you put an object on the weighing machine, you can see that it has a weight. This weight is the downward gravitational pull of the earth. It is a force exerted by the earth on the object. Weight is a force and has direction. The direction is downward towards the center of the earth. Since weight is a force, its SI unit is Newton and not kilogram. The force is called the gravitational force of gravity. Mass is the measure of the amount of matter or substance in a body. It is a property of a body that cannot be changed by its location, shape, and speed. The SI unit of mass is kilograms or grams. The amount of mass a body has depends on the number and composition of atoms and molecules that make up the body. The weight, on the other hand, is a force exerted by the earth on the object. It is dependent on the planet's gravitational field strength. Let's look at this example. We have a car on the road. If we place the same car on the moon, what will be the difference? The moon has a smaller gravitational pull than the earth. The car will weigh heavier on earth than on the moon. Its weight is different. Assuming that the tire punctured and you need to lift the car to change its tire, you will find that it is easier to lift the car on the moon than on earth. However, because the mass remains unchanged, if there is a problem with starting the car, and if you try to push the car, it will be no easier to push it on the moon than on the earth. Back to our example of the box on the weighing machine. Note that although weighing machine is calibrated to display in grams or kilograms, it is actually a measurement of weight and not mass. All objects experience a pull towards the center of the earth due to the force of gravity. Hence, objects have weight and will fall to the ground. So when you work on dynamics question, one of the force acting on the object will be the weight, and its magnitude is its mass times the gravitational field strength G. In the course of kinematics, we learned that acceleration due to free fall is 10 meters per square second. In the course of mass, weight, and density, it is shown that the acceleration due to free fall is the same as the Earth's gravitational field strength. Hence, if you are told that an object has a mass of 20 kg, then its weight would be 20 times 10, which is equal to 200 Newton. In summary, weight is a force exerted by the Earth's gravity on the object, and its magnitude is given by mass times gravitational field strength, which is also the acceleration due to free fall.